Okay, welcome to video number 2, the second set of problems, 2, 5, 8, 11, etc., on the review worksheet. Number 2, what is the limit as x approaches 2 of f of x? Well, this could be a problem because at 2, we might be on, as we get close to 2 anyway, if we're less than 2, we're on the first branch. If we're more than 2, we're on the second branch. So I think I need to check both branches to see if, if they meet, if this thing is continuous. If not, then the limit won't exist. So this is what I'm worried about, is answer choice D. Let's use some formal notation here. So limit as x approaches 2 from the right. Now let's do the left first, just kind of go in order. That would be this one. So 2 from the left would be that side. So I'm going to use this equation and plug in 2. So natural log of 16 over 2. All right, let's just leave that alone and do the other one and see if we learn anything. From the right, limit as x approaches 2 from the right. So from the right would be that side. So that's going to be 2 natural log 2. So question is, are those two things the same? And that's the proper response of, not sure, because properties of logs are kind of weird, so maybe they are the same. Algebra 2 teacher just walked by, so you could jump in and help on this. We could put the 1/2 as the exponent. So that's 16 to the 1/2. That would be natural log of 4. And then same thing here. Put the 2 as the exponent. 2 squared is 4. And so they are the same. They're both headed toward natural log of 4. So the limit is natural log of 4. That was a tricky one, because there was some concept stuff going on about left and right and limits, but then just some algebra stuff of, rules of logs. Number 5. 4 and 5 are pretty similar, because horizontal asymptotes, those happen as x goes to infinity. So 4 says, what's the limit as x goes to infinity? 5 doesn't phrase it that way, but it's the same. It's the same process, because it's the same type of answer, even though the question is phrased a little differently. So really, what we want on all of these is the limit as x goes to infinity, and then see if that's equal to 3. So as x goes to infinity, that's the shortcut. Top no, bottom o, equal co. So let's see on the first one. Looking at those lead terms, that would be -3. Whoops. So yeah, that doesn't work. It's -3, not 3. For statement 2, the top's bigger than the bottom, so that's a top no situation. So there is no horizontal asymptote for number 2. And then for number 3, we get 3, so that one works, so 3 only. But maybe the main part of that is this idea that horizontal asymptote means what's happening as x goes to infinity. Number 8. For h very close to 0, that sounds like limit as h approaches 0, which of the following function best approximates that? Okay, well, I don't know what in the world that is, but when I read for values of h close to 0, that makes me think limit as h goes to 0.
Couldn't you also just recognize that was the finding the derivative of secant.
And now so be careful, it's not the derivative right here, but with the limit on there, it is the derivative of secant. So there's nothing to do other than to recognize that this is asking me, or it's the same thing as the derivative of secant, and derivative of secant is secant tangent. So there's this small category of problems that are like recognize the definition of derivative problems. You don't really do anything other than know the derivative of kind of whatever's in that f of x spot. Number 11. Slope of the line tangent to the graph, so that's fancy word for derivative. This looks like chain rule going on here. I think we mentioned yesterday that when in doubt, pick the longest answer. I don't think that's the best way to go, but it's not a bad way to go for a chain rule problem. Although these are all pretty close to the same, I would be very suspicious of A. That doesn't look like enough chains have been added on there. So we'll handle the 3 first. Power rule. So 3 times the insides squared. Then working our way in, the derivative of cosine is negative sine. Leave the inside alone. And then one more inside, the derivative of 2x is 2. And then it's just a matter of collecting all the things. 3 negative 2 is negative 6. Cosine squared times sine, so it's answer B. So it was maybe not the longest written out, but the most complicated answer. Number 14. Yes, 14. Which of the following statements is true? Okay, so something weird is going on at negative 2. Let's look at this piece first. I'm going to factor out a 3, then factor what's left. And then the x plus 2's cancel. So that takes care of the whole. So that means now I can plug in negative 2 and get an answer, except I don't really want to plug in negative 2, because if I'm plugging in negative 2, I'm on this branch. So limit exists. Well, limit means coming from the left or from the right. But whether I'm coming from the left or the right, I'm definitely on that top branch. So it exists. I don't really care what it is, but may as well plug it in. That would be negative 12. So yes, basically there's a hole at negative 12. For the first, from the first function, there's a hole at negative 12. Continuous will ask, well, does this second piece fill the hole? So let's check the blue one. Negative 2 squared minus 2 times negative 2 minus 20. So that would be 4 plus 4 minus 20. That would be negative 12. So yes, the hole is filled. So the top one says there's a hole at x equals negative 2, and in fact it's at negative 2, negative 12. This bottom one fills the hole filler at negative 2, 12. So that one's true. And I don't know what this graph looks like, but it's differentiable. Like there's not a hole there. It's nice and smooth and continuous. So 1, 2, and 3 are all true. So kind of a weird question. Thinking about holes and is the hole filled or not. 17. The graph of g of x is shown at the right. Which of the following has the greatest value? G prime, G prime, G prime, G prime. So I'm looking at G prime in all these places. What is G prime on a graph of G? Like, what am I looking for? Slope. So I want to know, where is the slope the greatest? So there's A, there's B, there's C, and there's D. So the greatest slope would be at A. That's the steepest, most positive slope. No idea what the value is, but I can tell by looking it's steeper at A than any of the other points. Number 20. Relatively straightforward derivative problem, but I am going to rewrite that x to the third in the bottom as x to the negative 3. Some people do that in their head, but they usually end up with an x squared in the bottom because they reduced the power by 1. But if you rewrite it like this, you won't make that mistake. 1/3 times 3/4 times x to the 3/4 minus 1 is negative 1/4 plus 15 x to the negative 4. Okay, well, they both have 15x to the negative 4. These cancel. 1/4, but that negative 1/4 will send it to the denominator, so the answer is B, x to the 1/4 in the bottom. We like those, pretty straightforward. 23, average rate of change. That's good old algebra slope. So yeah, this is an Algebra 1 question, sneaking into our pre-cal packet here. So I need f of 4. 2 times 4 is 8, minus 7 is 1, 1 squared is 1. F of 1, 2 minus 7 is negative 5, squared is 25. So 1 minus 25 over 4 minus 1. The negative 24 over 3 is negative 8. So not really any pre-cal, not really calculus, other than knowing what average rate of change means. (26) What is G prime? Or where's G prime at 3? Okay, well, I'm changing this another piecewise. Like I'm hopping graphs at 3. So I need to see if there's a jump, then there's no derivative at all, and if there's not a jump, then I need to see if there's a cusp. So I need to check the function at 3 on both parts. And if those match, then I'll check the derivative of 3 on both parts. So for the first one, I'm just plugging in 3, 2 sine of 3 pi over 2. Sine of 3 pi over 2 is negative 1. So that's negative 2. I plug it into the bottom one. When I plug 3 into the 2x squared minus 20, let's see, 9 times 2 is 18. 18 minus 20 is negative 2. So it is continuous. They do touch. So that means it still might be non-existent because there might be a cusp there. So I need to check the derivative from each side to see if there's a cusp or to see if it's smooth. So G prime, derivative sines cosine, 2 cosine pi x over 2, but don't forget the chain rule, times pi over 2. And the derivative of this guy would just be 4x. Okay, if I plug in 3, there's no way I'm getting the same thing, right? Because the bottom one's going to be 12. the top one's going to be, I don't know, not 12 though, right? Because whatever this is, multiplied by pi over 2, how's that for an answer? Not 12. So that means one slope is 12, one slope is not 12, so that means there is a cusp here. So non-existent. So that's tricky. For those piecewise functions, at the jump, you have to check continuity to make sure they're just touching at all, but then you also have to check to see if they're smoothly connected or cusply connected, if that's a word. (29) What is the slope of the line tangent to the graph at x equals pi over 4? Okay, so this is like straightforward, take a derivative, plug in pi over 4. Although, you need to be careful because this is product rule. So, first times derivative of the second plus second times derivative of the first. You don't need to write that out, but if it helps you, keep track of things and where the pieces go. So, the first is x, derivative of cotangent. Derivative of tangent is secant squared. So derivative of cotangent is negative cosecant squared. Second is cotangent of x. Derivative of the first one would just be 1. And then I've got to plug in pi over 4. Let's see, plug in pi over 4. Cosecant of pi over 4. Okay, pi over 4 is in the middle. Cosecant goes with sine. Sine is root 2 over 2. But I need to flip that over. Alright, I've reached my limit of doing stuff in my head. When I flip over root 2 over 2, get 2 over root 2. Square it. Cotangent of pi over 4, that's x over y. It's the middle one, so that's just 1. That was nice. So let's see. Pi times 4 over 8. Yep. So pi over 2 plus 1. Uh-oh. What did I do wrong? Oh, I left off the negative sign. Negative, 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 negative. So get a common denominator, 2 minus pi over 2. A little bit of calculus, a little bit of algebra, a little bit of trig, a lot of stuff thrown in. (32) Find the slope of the line tangent to the graph. So again, that's derivative. Another product rule problem. First times derivative of the second plus second times derivative of the first. Don't have to write that out, but again, if it helps some people to keep track of all the different pieces, then maybe it's worth it. So first is e to the x. Derivative of the second, let's see, 1 over 4x. Natural log 9 in the bottom, but then also times 4 from the chain rule. The 4's will cancel, so I could cancel them now or cancel them later, either one. Plus the second, log base 9 of 4x, times derivative of the first, which is just e to the x. Now we get to plug in 1/4. Alright, we cancel the 4's. So e to the 1/4 over 1/4 natural log 9 plus e to the 1/4 log base 9 of 1, because 4 times the 4th is 1. Log of 1 is 0, right? 9 to the 0 is 1, so that goes away. Now we're down to just this piece. But a 1/4 in the denominator flips up to be a 4 in the top. So answer choice B. That's another one where there's a lot of trig. Oh, no trig. A lot of calculus and a lot of algebra in that one problem. Goodness, more product rule for 35. First, times derivative of cosecant. Secant goes to secant tangent, so cosecant goes to negative cosecant cotangent. Almost forgot the chain rule. Times 2. I don't see any 2's out here, so I'm curious what's going on here. So that was first times derivative of the second, and then plus the second, cosecant 2x, times derivative of the first, which would be negative e to the negative x. Okay, look at my answer choices, and they all have negative e to the negative x canceled or factored out. So let's factor that out and see what's left. Oh, they all have cosecant 2x factored out, so let's do that as well. And then what's left is 2 cotangent 2x minus 1. Why is that not an answer choice? What did I do wrong? Or is it an answer choice? First, derivative of the second. Derivative of cosecant is negative cosecant cotangent times 2. Plus second times derivative of the first.
The derivative of the first and the derivative of the second.
I think this is right, because this is the first, and that negative came from the derivative of cosecant. I factored out. Oh, I see what I did. I factored out a negative, but then I forgot to take out this negative, so that should be a plus right there. Algebra. I'd say almost got me, but it's probably fair to say it got me. Guess I was fortunate that my answer choice wasn't there, so I had to go back and find my mistake. (38) Limit as x goes to infinity. Well, it looks like both of those are headed toward infinity. So this is one of those like, well, which infinity is more infinity than the other infinity? So which is the stronger infinity, e to the 3x or 5x? I feel like this is an easy one. E to the 3x is a stronger infinity. So it's like big infinity over weak infinity. No offense to 5x, but this is headed toward infinity. If you were not sure about that, the L'Hopital's rule would work, because infinity over infinities is what triggers L'Hopital's rule. So that would be 3e to the 3x over 5, and now that is definitely going to infinity. So if you forget the rules, you can sometimes use L'Hopital's to still get the right answer. 41. X approaches 2. Okay, so don't do L'Hopital's. Well, not yet anyway. Plug in 2. Always plug in first, right? Because you never know what will happen. Maybe we get lucky. 4 minus 3 times 2 plus 2. 6 minus 6 is 0. Uh-oh, I'm suspicious. 4 minus 4 is 0. So now I can use L'Hopital's, or I could, that probably factors. So it doesn't matter. This unit had L'Hopital's in it, so I think I'll use L'Hopital's. But if you'd rather factor, you certainly can. 2x minus 3 over 2x. Limit as x approaches 2. So 4 minus 3 is 1. 2 times 2 is 4. 1/4. All right. Links available elsewhere for other videos. Make sure you like and subscribe to catch all the favorite content of your favorite pre-cal teacher.